What if I told you that an ecological disaster could actually be a scientific breakthrough? Today, we're diving into the story of one of Europe's most feared invasive species and a really valuable secret that's hidden right inside its body. So, let's meet the villain of our story, the Asian hornet. And what you're looking at here is where we begin, with a literal pile of pests. These guys are a formidable and very unwelcome guest across Europe. And, for some really good reasons.
All right, let's get a bit formal for a second. Its scientific name is Vespa velutina, but honestly, its reputation totally precedes it. We're talking about a species that has caused some major headaches for ecologists and beekeepers alike.
So the story goes that it all started around 2004. At least one hornet queen probably hitched a ride from Southeast Asia to France. And from there, it's just been a story of rapid, unstoppable expansion into Spain, Portugal, Italy, Germany, you name it. But here's the real kicker, its diet. The Asian hornet is an incredibly effective predator of the European honeybee. See, our honeybees have no natural defenses against it, unlike their Asian cousins. This doesn't just put honey production at risk, it threatens to destabilize entire ecosystems that depend on those bees for pollination. So yeah, a huge problem, no doubt about it. But what if we could totally flip the script on this? What if the very thing causing all this trouble could also be a source of incredible value? And this is where this story takes a really cool turn. Researchers started to look past the pest label and see the potential of the organism itself. They started tapping into a hidden resource that's, well, literally flying all around us. So what is this secret resource? Well, it's a little thing called chitin. You might not know the name, but you definitely know its work. It's a biopolymer, think of it like a natural plastic, and it's the second most common one on the entire planet. It's that tough, flexible stuff that gives insect shells and shrimp shells their signature crunch. Now, this is where it gets really interesting. For the longest time, we've gotten our chitin from shellfish waste, crab and shrimp shells left over from the fishing industry. But that supply can be pretty unreliable, and the quality is all over the place. What this research suggests is that insects, especially the endlessly abundant Asian hornet, could be a total game changer. They offer a stable supply, potentially a much higher and more consistent quality, and it might even be cheaper and easier to process. So, the big question is, how on earth do you turn a pesky hornet into a high-tech polymer? Let's follow that scientific journey, from trapped insect to a pure, usable material. It actually boils down to a surprisingly straightforward three-step chemical recipe. First up is demineralization. The hornets get an acid treatment to remove all the inorganic stuff like calcium carbonate. Next, they get an alkaline bath for deproteinization, which strips away all the proteins. And finally, a decolorization step gets rid of any pigments, leaving behind this pure white chitin powder. And here it is, the big reveal. This just says it all, doesn't it? On the left, you've got the raw material, the problem. And on the right, you have the solution. A clean, valuable biopolymer, ready to be used in everything from medicine to agriculture. It's an absolutely remarkable transformation. Okay, so we've made this stuff, but is it actually any good? Let's dive into the analysis and see how this hornet-derived chitin really stacks up. First key number, yield. How much do we actually get? The researchers found that the hornet's dry body weight is 11.7% chitin. Now, that might not sound like a lot, but it's right in the typical range for insects, which is anywhere from 10 to 36%. So this proves it's a totally viable and substantial source. And here's the number that tells us about quality. It's called the degree of acetylation, which is basically a key measure of how pure the chitin is. Think of it like a quality score. A perfect theoretical score would be 100%. At over 95%, the chitin from these hornets is exceptionally pure. That means it's high-grade material, good enough for some really advanced applications in medicine and science. But numbers only tell you so much, right? To really understand a material, you have to see its structure. So let's zoom in. Way, way in. Whoa, okay, so under a scanning electron microscope, the material just comes alive. What we're seeing here is a complex, layered structure made of nanofibers. This kind of intricate organization is exactly what gives the material its strength and all its useful properties.
And check this out. In other spots, you see something totally different. This is a smoother surface, but it's dotted with these tiny little nanopores. And features like this are incredibly important for things like biomedical applications. I'm talking about creating scaffolds for new skin to grow on, or designing systems that deliver drugs exactly where they need to go in the body.
So how durable is this stuff? This table shows us the material's half-life. That's just the time it takes for half of it to break down. And at room temperature, it's incredibly stable. We're talking centuries. But as you crank up the heat, that stability drops off pretty fast. So the main takeaway here is that while it's fantastic for a lot of uses, the researchers point out it probably shouldn't be used in any application above 60 degrees Celsius, where its half-life drops to just a single year.
All right, let's zoom back out and look at the big picture. What does all of this really mean for science, and maybe more importantly, for our relationship with the environment?
Here's the bottom line. This research gives us a brilliant model for what's called a circular economy. It takes a massive biological threat and turns it into a valuable, high-demand resource. This isn't just about getting rid of a pest, it's about creating value from it. We're getting a super high-purity biopolymer from a sustainable and, unfortunately, probably ever-growing source.
And look, you don't just have to take my word for it. The scientists who did the work say it best. Their conclusion says the Asian hornet is a promising alternative source precisely because it's so abundant and the quality of the product is so high. It's a really powerful endorsement of this whole idea.
And that leaves us with one last fascinating thought. If we can find this much value hidden inside the Asian hornet, what other problems out there are just solutions we haven't discovered yet? What other invasive species are just waiting to be transformed?